Welcome everybody to our channel. Today we should learn the most important topic of our statistics, that is standard deviation, which is considered as the most powerful and best measure of dispersion. So let's start our today's topic, standard deviation. Standard deviation means the positive square root of arithmetic mean of squares of the deviations of the variables from their arithmetic mean is called standard deviation. Generally, it is calculated by taking the deviations of the variables from their arithmetic mean, and then we should square root the arithmetic mean of the squares of deviations, which is denoted by small sigma. That is, it is always denoted as small sigma, which is derived from the Greek word. So the positive square root of arithmetic mean of squares of deviations of the given variables from their arithmetic mean is called our standard deviation, which is otherwise known as the root mean square deviations. It is otherwise known as root mean square deviation. So the standard deviation is otherwise known as a root mean square deviation, which is always denoted as small sigma, that is derived from the Greek word, and it is considered as the most powerful and the best measure of dispersion. So now come to the various features of our standard deviation. So its features are: it is rigidly defined. Next feature is it is not affected by fluctuation of sampling. It is affected by extreme items. The next feature is it is amenable for further algebraic treatment. Then our next feature is it considers all the items of a distribution. Then our next feature, it establishes empirical relationship with other measures. So let's repeat again the various features of our standard deviation. Is it is rigidly defined and it is not affected by fluctuation of sampling. It is affected by extreme items and it is amenable or capable of further algebraic treatment. It is considers all the items of a distribution and it establishes empirical relationship with other measures. So here empirical relationship means the relationship which is developed by experiment and observations. That means there is no relationship or the relationship which is developed by theory. That means the relationship with other measures are developed through experiment or through the observations. That means it is not developed by any theory. So these are the features of our standard deviations. Now come to the various advantages of our standard deviation. So the advantages of our standard deviation, it is rigidly defined. Then second advantages, it is not affected by fluctuation of sampling. Then our next advantages, it is capable for further mathematical treatment. Then our next advantages, it establishes empirical relationship with other measures. Then our next advantages, it considers all the observations of a series or distributions. So these are the advantages of our standard deviations. Let's repeat again. It is rigidly defined, that means it is clearly defined and it is not affected by the fluctuation of sampling. That means if we change the samples or there is a change in any samples, then the standard deviation is not affected. It is capable of further mathematical treatment. That means other calculations are also based on standard deviation. That means we can measure or we can calculate other statistical measures like hypothesis or any test, that is x square test, kt square test, or any other statistical measures can be calculated by considering our standard deviation. It establishes empirical relationship with other measures. That means which is developed through experiment or through the observations, but not by any theory. It considers all the observations of the series. That means when we should calculate standard deviation, we should consider all the observations given in a series or distributions. Now come to the disadvantages of our standard deviation. So the disadvantages of standard deviation is it is difficult to calculate. It is difficult to calculate. It is the next disadvantages is it is not easy to understand. Then our next disadvantages is it is very much affected by extreme items so these are the disadvantages of our standard deviations. So standard deviation, let's again repeat the disadvantages. It is difficult to calculate, it is not easy to understand, and it is very much affected by the extreme items. So these are the advantages and disadvantages and features of our standard deviations. So make notes. Now come to the various properties of our standard deviation. So our properties of standard deviation are: it is independent of change in origin. That means the value of standard deviation remains unchanged with the change in the variables. That means if we add or subtract the variables of a given distribution by a particular constant, then the value of our standard deviation remains unchanged. Whereas our next property is, it is dependent of change in scale. Here the value of the standard deviation changes with the change in the value of variables. That means if we multiply or divide the variables of a series by a particular constant, then the value of our standard deviation is also multiplied and divided by the same constant. Then our next property is, it has empirical relationship with other measures of dispersion. Here empirical relationship means the relationship which is supported by our experiment and observations, and there is no such rules or there is no such theory that support the empirical relationship, which is otherwise known as phenomenological relationship. So here our next property is, it is the sum of squares of deviation from their arithmetic mean is minimum. That means if we take the deviations of the variables from the arithmetic mean, then their sum should be minimum than any other measures. If we take the deviations from other measures, then our next property is the standard deviation of n natural numbers, or that is our natural numbers, is n square minus 1 by 12 whole root over, and it is also amenable for further algebraic treatment, or we can also compute the combined standard deviation, that is which is denoted as standard deviation of two groups, that is standard deviation of 1 2 and standard deviation of 3 groups, which is denoted as standard deviation 1 2 3, which is calculated by using the rules, that is n1 into standard deviation 1 raw square plus n2 into standard deviation 2 raw square plus n1 into d1 raw square plus n2 into d2 raw square divided by n1 plus n2 raw whole root over. So these are the properties of our standard deviations. So here empirical relationship with other measures of dispersions, that is standard deviation QD equals to 2/3 of standard deviation and MD equals to 4/5 of standard deviation, and our range is 6 times of standard deviation. So these are the empirical relationship of standard deviation with our other measures of dispersions. It is otherwise known as phenomenological relationship. So now come to the different methods of our standard deviation. So first of all, you make the notes. Now come to the different methods of our standard deviation. Generally we use 5 methods for the purpose of computing our standard deviation, that is direct method, where we should consider the direct variables or given variables of a series or distributions, and our second method is shortcut method, which is otherwise known as assumed mean method. Here we should consider the deviations taken from the assumed mean for the purpose of computing standard deviations. And next one is our step deviation method, where we should divide the deviations taken from our assumed mean by the common factor for the computing standard deviation. And our next one is arithmetic mean method, where we should consider the deviations of the variables taken from the arithmetic mean should be taken for the purpose of computing our standard deviations. And our last one is shortest method, where we should use a special rule, or we should consider the cumulative frequencies of the series or distributions for the purpose of computing our standard deviations. So let's note the rules of standard deviation under different method. So in case of our direct method, standard deviation is calculated by using the certain rules, that is square root of summation x square by n minus summation x by n row whole square. And in case of our discrete and continuous series, we should multiply the frequencies with the variables for the purpose of computing a standard deviation, that is whole root of summation fx square by n minus whole square of summation fx by n, and in case of shortcut method we should use the deviations which is taken from the assumed mean for the purpose of computing standard deviation, that is standard deviation equals to whole root of summation d square by n minus whole square of summation d by n, and in case of discrete and continuous series we should multiply the frequencies with the deviations, that is summation f d square by n minus whole square of summation f d by n, and in case of step deviations method we should divide the deviations by the common factor or the class intervals of the series or distributions, that is standard deviation equals to whole root of summation d dash square by n minus whole square of summation d dash by n, and in case of discrete and continuous series our standard deviation is whole root of summation f d dash square by n minus whole square of summation f d dash by n into I, and here also I should be multiplied, that is common factor or the class intervals. In case of arithmetic mean we should consider the deviations from arithmetic mean for the purpose of computing our standard deviation, that is standard deviation equals to whole root of small x square by n. Here small x is calculated by differentiating variables by the arithmetic mean of the given series or distributions, and in case of frequencies we should multiply the frequencies here, and in case of shortest method our standard deviation is calculated by considering the cumulative frequencies. So the rules of shortest method is I whole into whole root of 2 f2 minus f1 and minus f1 square. So here I is the class interval or common factor, and f1 is the arithmetic mean of cumulative frequencies, and f2 is arithmetic mean of cumulative frequencies. So these are the rules of our standard deviations. So in case of direct method we use the direct variables. In case of shortcut method we use the deviations from the assumed mean. In case of step deviation method we use the deviations which is divided by the common factors, and in case of arithmetic mean we compute the deviations, that is small x, which is computed by differentiating x minus x bar, that is the arithmetic mean of the given series or distribution. And in case of discrete and continuous series we also compute the standard deviation, that is whole root of summation f x square by n, and in a case of shortest method our standard deviation is I into whole root of 2f2 minus f1 and minus f1 square. So here I equals to class interval or common factor. F1 is the arithmetic mean of cumulative frequency and F2 is the arithmetic mean of cumulatives of our cumulative frequencies. So note all these rules. Now come to the various relatives of our standard deviation. That means some other measures which is completely based on our standard deviation, that is known as the relative of our standard deviation. So these are coefficient of standard deviation, which is considered as the relative measure of our standard deviation is called coefficient of standard deviation, which is calculated as by using the rules SD divided by x bar. So our coefficient of standard deviation is calculated by dividing the standard deviation by the arithmetic mean of the concerned series. Then our second relative is coefficient of variation, which is the expression of coefficient of standard deviation in percentage form. So it is calculated by multiplying 100 with our coefficient of standard deviation. So the coefficient of variation is standard deviation by x bar or arithmetic mean into hundreds. That is the expression of coefficient of standard deviation in percentage form is called our coefficient of variation. Then next relative of standard deviation is our variance, which is the square of our standard deviations. That is variance equals to SD square or standard deviation square is known as our variance. And then the next relative of our standard deviation is combined standard deviations. That is the standard deviation which is calculated by combining two or more series or more distributions is called our combined standard deviation, which is computed by using the rules, that is n1 standard deviations 1 square plus n2 standard deviation of 2 square plus n1 into d1 square and plus n2 into d2 square divided by n1 plus n2's whole root over. That means in case of combined standard deviation is the standard deviation which is calculated by combining two or more distributions or series. Here d1 is calculated by differentiating x bar 1 and x bar 1 2, that is arithmetic mean of first group and arithmetic mean of two groups, that is combined arithmetic mean of two groups. In case of when there is three series or three distributions are given, then x bar 1 or d1 is calculated by differentiating x bar 1 with x bar 1 2 3, and d2 is calculated by differentiating x bar 2 and x bar 1 2, whereas in case of three groups, that is x bar 2 minus x bar 1 2 3, and in d3 is calculated in case of only three groups, which is not calculated or which cannot be calculated in case of two groups. So in case of three groups, x bar 3 minus x bar 1 2 3. So here first of all we have to compute our combined arithmetic mean of two groups and combined arithmetic mean of three groups, that is n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2, and in case of three groups, that is n1 plus n1 x bar 1 plus n2 x bar 2 plus n3 x bar 3 divided by n1 plus n2 plus n3. So these are all about relative of our standard deviation. So repeatedly watch this video in order to develop a clear knowledge on standard deviations, and also share it with all your friends to give them opportunity to develop their knowledge on standard deviations. So the various problems or the problems based on different methods should be uploaded in our next videos. So in order to get the notification, you must like, share and subscribe our channel. Thank you.